right, this is just an AI agent. You can see I've got my Claude API up here. Has no idea how my shipping system works. And watch as I ask it a question. What is the status of order ORD 10432? And you can see it thinking here for a second, and it's looking it up. And boom, it says, my order is in transit via Acme Freight, estimated delivery on 7/19. So, this AI agent has reached into a .NET MCP server that I wrote and found the answer to the question that I asked it to. And over the course of this video, I'm going to show you how to build that server from scratch and do it in a clean architecture way so that it's both clean and testable and something that will last. I'm Barrett with Nibble Pros. Let's get into it. So let's start with the mental model that kind of makes all of this click. Your team maintains a source of truth. That might be an internal API, it might be a set of use cases, a set of coding standards, an FAQ. Each one of these things has a delivery mechanism, whether it be a controller, an endpoint, a CLI, a database, a web interface, whatever it might be. An MCP server is really just another delivery mechanism. It's just another way of getting at that information and presenting it to the end user. The difference with an MCP server is that the end user is your AI. Once you treat an MCP server just the same as any other delivery mechanism, every other skill, everything that you've learned about how to deliver information to a user, it all applies. It's just a little bit different. So what we're going to kind of talk about today is we're going to talk a little bit about what MCP is. We're going to go through our demo scenario here. We're going to talk about the wrong way and the right way to implement that kind of thing. Talk about how to implement failures in a way that AI can take full advantage of that, and a little bit about testing, debugging, and shipping it at the end. And of course, we'll have a full demo, and the code will be available on our GitHub repository. We'll make that available as well, and a link will be in the description. So let's start with what an MCP server is. So as I mentioned, it's just another delivery mechanism. It's a way of exposing information, not so much directly to the end user, but to an AI agent. An MCP server will have tools and resources and prompts that make the AI agent able to interact with it. And we'll talk a little bit about what each of those are as we go through this. The client, instead of being the end user, it's an AI agent that the end user is using, whether it be a chat agent, a CLI tool, whatever it might be. The logic of delivering that information, of interacting between the AI agent and your MCP server and the facilities that the MCP server makes available, it works, it's transport independent. It works over HTTP. It works over standard IO, whatever it might be. It's just, as I said, it's just another delivery mechanism. With .NET, there's an SDK that Microsoft has created that handles all that protocol information for you. All you have to worry about is writing the .NET code, and that's what we'll get into today. So a little bit about what an MCP server provides. So there are really three things that it provides. The first thing is tools. Those are the actions that the AI agent can take. Those are the commands that it can issue to the tool, to the MCP server. It says, okay, I want to do this, give me this. The next thing that an MCP server provides are resources. These are basically read-only blocks of information that the AI tool can use as part of its context. It might be information about what it provides. It might be information related to what it provides that adds additional context to the query or to the prompt that the end user might have. And then there are the prompts themselves. Those are the templates that the MCP server can suggest, saying, okay, if you want to know about this, ask it in this way. And it provides that information to help the AI agent interact with the MCP server and what it can do. but also to provide prompts, suggestions to the end user who's using that AI agent, saying, if you want to know about this, this is how you would ask to get the most effective results. In our scenario today, we're going to do an order shipping tool. Maybe you have some kind of shipping service that you're shipping a product to a customer. You want to make a tool available on your website so that a customer can log in and ask the chat tool, hey, what's the status of my order? And it can provide that information directly to the end user through that MCP tool. And what the MCP tool that we'll create will do, will kind of create that interface between the shipping information and the question on the front end. And there are a couple ways that you can do this. Now, obviously, you can do it the quick and dirty way, and the thin tool in this particular case, where you would take your MCP template in .NET and just throw the DB context straight into it. You can throw all the domain logic, everything into that front end. The problem with that is it's not testable, it's not reusable. The more that you add to it, the less reusable it becomes in the long run, less maintainable it becomes. So obviously we want to do it in a proper way that kind of breaks that apart. And we'll use clean architecture as part of our design process, so that we can separate those concerns. We can keep things separate one from another. We'll use command query and handlers and keep all that business logic and the DB context and all that stuff separated from the presentation layer so that it's testable and reusable and expandable in the long run. The MCP tool itself will live at the edge. The prompts, the interfaces, the protocol communication stuff, all that will be at the presentation layer. And then we'll have, of course, the application layer and the domain layer and the infrastructure layers below that will separate out those concerns, make them reusable, make them testable. It's just basically the standard clean architecture approach. So the way that the sequence of events as things will happen, the agent will call the tool over this protocol, and the protocol that is used for communication between the MCP server and the AI tool is just standard JSON RPC. It's plain text in JSON format. The request going up puts it into that structure. The response coming back puts it into that structure as well, so that the AI tool can break it apart and understand what's what. The tool will send the query. Say, hey, I want to know about this particular order that I'm asking about. Calls that sender. The handler in the back end gets that request. Says, okay, I want to know about this. Hands it off to the handler. Makes that call to the repository. The repository gives the response back. And for our demo today, we're just going to use an in-memory response. But you would obviously have it tied, for a production model into your database or whatever tool it is that you have on the back end to retrieve and keep track of that information. The response that comes back will be put into a standard result structure and send that back. And we'll talk a little bit about why we're going to do that later on. But the short version is it puts it into a structure that if there is an issue or an error and it can't give a good response, that the AI tool will understand that and also understand how to prompt the user to maybe ask the question in a better way. And we'll demonstrate that as we get back into it. And then, as part of that, putting it into that structured content, it puts it in a format that the AI agent can understand, as I said, so that it's able to reason out, when something goes wrong. Here's, instead of just saying an error, oh, sorry, we couldn't help you. Instead, it provides a context or response, something that it will be able to help it to provide a potential solution to fix the problem. So starting to get into the code a little bit here. So we'll start with the registration piece. And this obviously goes into your program.cs or wherever it is that you're doing, all of your initial application setup. For an MCP server, we start with this .add MCP server, and that's the basic setup, and it includes all the information for the template and how to add saying this is an MCP project. Then you would define your transport layer. So in this particular case, we're going to use standard I/O. You could have HTTP streaming, or there's also some legacy transports that are available that you won't want to use, but the two main ones that you'll use are either standard I/O server transport or HTTP transport. Those are the ones you want to know about. And then you'll have 1 to 3 additional things here, depending on what your MCP server provides. We talked about what tools are, what resources are, what prompts are. If you're providing each of those, then you would add that, from the from assembly pieces here. That's just saying, okay, go look through my code, through my assembly, find all the tools, find all the resources, find all the prompts, and register them as part of the application so that it can respond to those things when they're running. In the presentation layer, you're going to define those prompts, tools, and resources. And you'll do it with attributes. So, for this particular case, for the tools, you define the class as an MCP server tool type, or you attribute it as that. So it's saying, okay, this class has tools. And then for each of your functions that is a tool, you'll attribute it as the server tool here, MCP server tool. And then, you've got the functionality in there. And of course, because we want to do this in the clean architecture way, we just want to have it set up the handler and call that handler and then return the result. We don't want any additional logic in here. But there is one more key piece here that we do want to add, and these are these description attributes. So this is where a lot of the heavy lifting for a tool is, or for the prompts and the resources. This is telling the AI agent what these things are. So go back here and look at this. You've got a description on the function itself, and you've also got a description attribute added to the parameter. So in this particular case, we've got a description on the function that says this gets the shipment status for an order, and then a description for the parameter. So order number, this is what an order number is. So obviously you pass in an order number, but this will let you provide descriptions that help the AI agent know what pieces of information to hand off into which parts of the function, and also to help the end user who's using the AI agent to know how to ask and how to provide that information. And these are critical pieces to defining your tools, because those provide a lot of context and a lot of structure to the AI agent. As it says here, you want one on the method and you want one on each of the parameters, and you want those to be useful and descriptive. Don't provide vague descriptions. Otherwise, the AI agent can't reason out what it is that the function does, and what information needs to be passed into that. As I mentioned here, treat it like API documents. Treat it like like how you would describe something to a new developer who has no idea what a function does. You want to describe it in a way that makes it useful and helpful. So the description attributes are really one of the biggest keys to the whole thing, and one of the most important parts. So as we get into the handler, this is, obviously in these layers further down, the application domain and infrastructure layers, the handler here is where a lot of the heavy lifting happens. And we'll look at the full code here in a minute as we get into the demo stuff. But in this particular case, we want to structure. So we've got a request coming in, but we want to structure the result in the standard format so that we can return useful information here. So in this particular case, we've got a guard clause. So when our blank input comes in, we're going to return an invalid response, and we want to return descriptions with that, validation errors, things like that, so that not only does the AI know that something did go wrong, but you're providing information about what needs to be changed to the request in order to fix it. A vague generic error doesn't help the end user, doesn't help the AI to address the problem with the request itself. So just as critical as the descriptions on the functions and the prompts, or the parameters, you also want to make sure that the responses going back, if there is an issue, include specific details on what is needed to fix that issue. So, if we've got success here, we just return that as part of the DTO with the result.success. And again, if it's invalid, if it's not found, whatever it might be that the issue is, make sure that you're including, specific information on what the problem is. So as I mentioned, make sure you give the agent an error it can act on. Be descriptive in those responses. Again, here, if the result is invalid, saying because it didn't include the required parameter, saying order number is required. If it can't find a result, saying okay, that order wasn't found. Make sure that the responses are useful and descriptive. And then as we get into testing, because we're doing it in the clean architecture pattern, you're separating that stuff out into the various layers so that you can make those testable. One of the key things here when you are working with MCP projects with .NET is that you always want to do the .NET build separate when you're doing the testing. So one of the tools that you can use to test with, here we go here. So there is an inspector tool that you can run for testing locally with your .NET MCP projects. So what you would run from the command lines, you'd run this npx model context protocol /inspector, and then you tell it where to find your MCP project. But the critical part is this no build parameter. So when it's running this, whether you're doing that as part of installing the MCP tool so that your AI agent can use it, or whether you're doing your local testing here with this model context protocol inspector, you always want to make sure that you're passing in this no build parameter, because the problem is that when it starts spinning up the application to test or to use for the AI agent, when you're running locally, it adds if it does that, and if you don't add that parameter, it'll do a lot of the build information as part of spinning up the project, and that output from the build operation from running .NET build will mess up the protocol communications protocol between that initial spin up between the MCP server and the AI agent. It'll screw up that communication, and it'll start throwing errors, and it won't be able to understand what's going on. So you always want to do a .NET build first, and then run the inspectors or run the MCP server separately. That way the output from your .NET build isn't getting included as part of that communications. So once you do run that, you'll get a application that spins up so that you can test locally here. Where are we at? There we go. And it'll spin up this page here. And it'll spin up this page here. And so what you'll get is this inspector tool. And it just basically gives you ways of testing the various pieces. So at the top, you'll see resources, prompts, and tools, whatever is available. So in this particular case, resources, you can do list resources. Clear that out and rerun it. In this particular case, we've got carrier service levels as part of the information. And remember, with resources, that's read-only information that's made available to your AI agent. In this particular case, we're just providing information about shipping carrier service levels. So particular case here, Acme Freight has ground and other information here. It's as I say, it's JSON information. Everything is in that JSON protocol format. And then, of course, we've got prompts here. In this particular case, I've only got one example prompt, and it's, delay notification. So, so what this does both provides information about prompts to give to the user, but also suggestions that the user might be given from the AI agent. In this particular case, the prompt. So if I did just a random number here and do get prompt. So this is, in this particular case, it's a suggestion back to the AI agent. So saying, okay, we couldn't find that order. Here's how you might tell them. So, tell the customer that we couldn't locate order 11231 and ask them to confirm it. But if I put in an order number that's valid and do get prompt, saying, okay, in this particular case, the order was delayed. And it's just, again, suggestion to the user or to the AI and how to respond to the agent, or sorry, how to respond to the user about how to provide information about their order. So it says, write a warm, apologetic email to the customer about their delayed order. Whatever it might be. And this, it wouldn't be an email. It might be just response to a chat, or it might send an email. However you want to set that up for it for that interaction to occur between the AI and the user. It's just providing suggestions back to them. And then tools, these are the actual tools. In this particular case, we've got the get shipment status. And if I put in an invalid one and run the tool, so it says no order was found for 1101. Or if I do order 10432 and run it, I think it's because I got an extra. There we go. So now I get a tracking number, an estimated delivery date, the carrier, status, basically all the information about their order. So this is a tool that you can use to test your stuff locally without having to run the AI agent itself, so that you can see the MCP server in action and be able to use it there. So let's go back over and look at this here. Just go through a few do's and don'ts. So again, I mentioned always run the .NET build first, and then when you're interacting with the actual AI or with the inspector, then you run it with no build, so that you leave out that .NET build information that can mess up the communications protocol. Make sure that you're including descriptions, and make sure you're keeping them very clear and descriptive. Return a result of T. That provides information in a structure that the AI agent can understand and to be able to make use of it in order to either provide a successful piece of information back to the user, or to be able to provide them with information about exactly why something was not correct and how to fix that. If you're doing a shared server, MCP, then you'd want to use HTTP. Otherwise, use the standard I/O especially if you're running it locally. For instance, if you were to make this as part of a RAG tool with another video that I created, then you would want to use standard I/O in that particular case. The SSE transport has been deprecated. You don't want to use it. It's still there for legacy purposes. So if you absolutely have to use it for whatever your setup is, then that is available to you, but you shouldn't use it otherwise. Make sure that your descriptions are not vague or one word. Don't put your DB context directly into the tool or into the presentation layer. You want to use that separation of concerns. Your clean architecture, so it's reusable and expandable, maintainable, testable. All the good ables. And then of course, don't use .NET Build as part of the part of spinning up the tool, because it will inject a bunch of text into there that isn't in JSON format, and it'll screw up the communication and throw errors, and the MCP server won't be able to communicate with the AI tool. Or sorry, vice versa. The AI tool won't be able to communicate with your MCP server. All right, so let's take a look at the code. Again, we had our example here. We have Claude running in this particular case, but it works with whatever agent. Let's say, what is the status of order 1, 1, 2, 3, 4? And it should come back and say, I couldn't find it. There we go. I couldn't find a order matching that. Could you double check the order number? So as you recall, the prompt information we gained back says, keep it under 120 characters, provide a warm response, and it provides an error back. Can you double check the order number? And it even provides an example. Here's what an order number should look like. Again, so okay, so let's start delving into the code. One of the easiest ways to do this, you could create it from scratch yourself, using the libraries that are out there. But Microsoft has provided a set of templates for creating MCP servers. So what you'll need to do first for that is to install the template if you don't already have it installed. So do .NET new install Microsoft.mcp server.project templates. Now I've already got them installed, but if you don't, then it'll get that installed. Then you just do .NET new MCP server, and then you give it a name. Let's just say, shipping status or whatever. And what that will do is create a new project. And you can see we've got that the project's been created there. I've got another one that I've already created that I'm going to walk through with you, but that's really all you need to do to get started, is to just install the template, create a new project from that template, and then you're off and running. So let's take a look at the full code here. Okay, now we'll get into the actual code files here in a minute, but I just want to do a once over of the full project creation here. So I've actually got 4 projects in my solution here. Now the MCP server, that would be the one that would be created by default from the template, but I've gone ahead and broken that out using the clean architecture structure here. So I've also got an application project, a domain project, and an infrastructure project. So if we just look at the program.cs in our main project here, you can see, here's the basic, setup for it. I showed you a minute ago on the slides here, the structure of how to register that once it's in the, once you've created that. I'm using Mediator. You could use whatever you want for communication. Within the project here, that's just a quick and easy way to get that up and running. But yeah, for your domain communication, you can use whatever you want. You don't have to use Mediator. There's all kinds of options out there for you. And within that, we've got some extensions files that we'll go through here in a minute. And then we've got our 3 types here, our prompts, our resources, and our tools. So we've got files defined for each of those for the, these are what get exposed to the AI as it's calling in the AI client. And I've got those defined in their separate folders here. And then if we go down here and look at, if we go down here, look at the application project here, you've got a couple of handlers and some interfaces here, some information about the orders itself. So it's just, structure around the application and what how it communicates back and forth. We've got our domain project here, which basically just has the shipments information. And then we've got infrastructure here, which is mostly just some setup stuff. So I've got my in-memory provider. If, for the demonstration here, I'm just doing in-memory. If you were doing a full application, obviously you would want to connect it to whatever the data source is that's providing that information. So that's what we've got there as far as the projects go. So let's start looking at some of the code files. Here we go. All right, let's start with the MCP tool. So we have, in this particular case, our tool here, and we've got the attribute here which defines it as a tool. And again, the attribute here with a description, and you can see the description is clear and detailed. saying keep or get the current shipment status by its order number, a description on the parameter. Here's the customer's order number, and e.g., here's an example of what an order number should look like. And again, the only thing that we're doing here is making a call deeper into our application. So if we go and look at our handler, again, get shipment status handler, the other handler. That's not what we want to look at. So our get shipment status handler. So again, we're doing the work here in the presentation or the application layer. Getting the if we don't have the required parameter, we're providing a detailed validation error. Then we go out and look for it. If we don't find a result, we're providing a detailed not found result, as long including a description of what's wrong and what it should look like. And otherwise, we return full success with all the information that was provided back in our tool. So again, if you look at that, if we go back to our prompt here, you can see if of order ORD 10432, and you can see it think for a second here. And here we go. So it's in transit via Acme Freight. Here's the tracking number and the estimated delivery date. And you can see we've got the order number, status, carrier, tracking number, and estimated delivery. So all that information was provided back to the AI tool. The AI tool is provided with an example of how to understand that, and is able to put it into a description and text that the end user can understand. So that is the code, and you can see it's very straightforward and simple here. And we've got an extension class here. It's our result to MCP extensions. So basically what this is doing is helping to structure it into a response that the standard response with the result status, along with a few helper information pieces here. So again, if I didn't provide a good explanation or a good error, it does provide for some fallback default error messages. So if not found, requested order cannot be found. If it's invalid, we try to get that list. If it's unauthorized, request not authorized, and so on and so forth. So just some helper methods here to help us get that output into a structure that the AI agent can parse and understand and deal with, whether it's successful or a failure, either one. So that's our helper class here. So resources. So I mentioned, we have this read-only information as a resource in the MCP server, and I've got the shipping resources here that is defined as a resource type and a resource. And again, we want a good description. So here are the carriers that we provide and their guaranteed transit times by service level, and it just provides some seed information that I've got defined down here in memory. In our infrastructure class here. So if I go down here and look at our carrier service level provider, and I've got a seed data here. So our seed data, if we go down here and look, so we've got our carriers. So I've got two different carriers and two different service levels for each one. And if we went back and looked at the inspector here and the resources, and if I were to expand that out again, all that information here is here in this JSON blob of text here that's available. And that's all here on seed data. And then, of course, I've got some sample information here as far as shipments. So let's ask about order 10500. So if I go back here, over here, the status of order or D dash, dash 10500. And it says, okay, 10500 has been delivered via global parcel GlobeX parcel. There was the tracking number, and it was delivered on the 16th. So you can see the seed data there. Okay, close that out. And then, of course, our resources, as I mentioned here, is basically just regurgitating that information out. You could put in whatever information that you want as resources. Just keep in mind that a resource is read-only, and it's there to provide additional context for the MCP tool. And then prompts, here this is the third type, so we define that with an attribute of MCP Server prompt type for the class. And then for each of the prompts, we've got the attribute of the prompt. Again, you want your detailed description and detailed description of the parameter. So again, this is pretty much the same thing because you're doing an order number. And this helps to, like I say, helps give the AI agent a way of providing information back to the user. So saying, okay, if the result was not a success, then you can say, okay, we couldn't locate the order. In this particular case, if you couldn't find an order number, or if you could find the order number but it hasn't been delivered yet, you might say, okay, we'll provide an email describing, we're sorry, it's not yet available or something, whatever it might be. Again, it's just providing information to the agent, the AI agent, and how to respond to the customer in this particular case, or to provide suggestions to the customer and how they might ask the question in a better way, or in a way that's going to get them more results. So you could provide a prompt around, the order number, saying, okay, with that, if you couldn't locate the order number, or maybe they're asking about something that's not related to an order. Maybe they're asking a question, that has nothing to do with shipping at all. You might provide a prompt that says, okay, well, if if your question isn't about the status of your shipment of your order, like, maybe something was missing from the order and they have a problem with the order. You might say, okay, well, in that particular case, you want to reach out to customer service directly or something like that. You can provide, prompts of all kinds of things to just basically to help provide guidance to the AI and how to respond when things don't go the right way. That's the best way to describe it, I guess. It's there, between that and providing detailed and quality error messages when something goes wrong. It's there to help the AI self-guide. I mean, there's nothing more frustrating to an end user using an AI chat tool than if the tool can't provide any kind of response. It's like, I don't understand. What do you want? I don't know what you want, kind of thing. That will become extremely frustrating to the client, to the end user, sorry. And it's a great way to leave them with a bad opinion of your company and your service and your products. But if you can provide those kinds of details to give them a more useful response, more useful way of dealing with things, you're going to leave them with a lot better feeling about having to interact with an AI. Because people in general, they hate AI. They understand that it's a necessary evil these days, but if you can leave them with a more positive experience in how it deals with them, you can make it more useful to them. You can make it more helpful to them. Then they're going to have a better experience and leave with a better impression of your company, even if things don't go right, even if they don't get the answer that they wanted. So that that's what that's there for them. So that's really all that there is to the this sample application. Like I say, it's very simple and it's just there to help kind of get you started with creating your own MCP server. And you could do it all within the MCP server code that you write yourself, or you could have it hand off and call out to some other tool. If you already have an API that's available internally, or a database or whatever it might be, that provides the information to answer the questions that you want your MCP tool to be able to answer. You just create that as an interface between the AI tool that's going to be calling in and where that information resides. But this should be enough to kind of get you started with creating an MCP tool yourself and having that kind of tool available for your AI chat agents to use. So let's go back here, just a couple last slides here. So let's say you create an MCP tool that you want to be available either internally as a NuGet package, or make available to the public. Maybe you create something that interfaces to something external, and you find it really useful, and you want to make it available for other people. Well, you can pack that up as a NuGet package, and then publish it out that way, the same as you would any other NuGet package. If you're doing a class library or whatever it might be, you can set up MCP tools to be delivered as NuGet packages. And then, especially with the newest versions of .NET 10, they can just run them, as a DNX, with the DNX command, run it right from the command line, the same way that you would the inspector that I showed you. So one of the things it'll do is you have to make sure that you set up in your server.json file, any inputs that would be required. So in this particular case, let's see, let's go back here to our code here. I don't think that I have anything set up in this one. Oh yeah, no, there is a database. So, if we were to set this up with like a database backend instead of an in-memory tool to return that shipping information, and if I was to publish this as a NuGet package, when you run that, it'll set up, it'll request, it'll either look for the shipping DB connection environment variable, or if it's not there, it will prompt the user for that the first time you run it, and then it'll save that as an environment variable, and that way you can make it available, you can make it useful to the whatever user is going to be using that. So if you have any environment variables or anything like that to set up, you would do that here in your server.json file in the .mcp folder, and then when you publish it and when somebody uses that NuGet package, it'll prompt, like I said, it'll prompt them if the environment variable doesn't exist already. It also includes that as part of the documentation in NuGet. They'll see that when they go out and try to download it, and if they go out and look at the resources on the NuGet website. So you just pack it up the same way you would any NuGet package. You push it out there, publish it the same way as any other NuGet package. And then, like I say, you can use the DNX command to run it from the command line, or you can install it and run it as part of something else. The same way, like I say, like any NuGet package, it works exactly the same way. It's just with the newest versions, you have the option of running it directly from the command line. So just a couple of the key takeaways again. Treat it like any other delivery mechanism. Set up the application structure the same way you would, especially use an architecture. You don't have to use clean architecture. We did that for our demonstration here. But you always want to make sure that whatever architecture that you're using, that you're making it reusable, that you're making it testable. Maintain that separation of concerns, however you want to structure it, and however you want to implement it, so that the presentation layer is calling into other tools that are testable and reusable. Keep the protocol at the edge, as I said, logic in the handlers, that kind of stuff. Make sure that your response is a well-structured response that provides details that are understandable, that are able to be easily digestible in JSON format. Result T that we're using here is an excellent example of way to provide that information, and the AI agent, whatever structure you use, make it in a format that the AI agent can understand and be able to recover from if there are issues and problems. And you always want to make your code testable. So again, like I said, whatever structure you're using, whether it's clean architecture or something else, make sure it's testable. And and you'll be a lot happier, and because your code will be a lot more maintainable in the long run. So I want to thank you for your time. Again, the application will be available in our GitHub repo, and there will be a link to that in the description. There's also there's also a link here to the companion blog post that was published a couple months ago about creating an MCP server in .NET. And of course, you can always find more information on our website. Thank you for your time, and have a good day.